So today is another lesson on factorization of quadratics. This time we're going to be looking at quadratics where the coefficient a, which is the number before x squared, is greater than 1. So I'm going to go through a couple of examples myself, and then you are going to finish off the examples, and then you can check your answers using the answer scheme I've attached in the description below. So let's get into today's video. In the previous video, I described that to factorize a quadratic, you need to find the multiples of the last number, which then you add those multiples together to give the middle number. But that's assuming that the value of a there is 1. So that only works if the value of a is 1. So what happens when it's greater than 1? Well, in this situation, you have to find the multiples of the first number as well. And then you trial which multiples it could be for the first number and the last number into the double brackets, and then expand out to see which one has worked. The first one is relatively straightforward. The multiples of 2, just 2 times 1, and then the multiples of 3, 3 times 1, and that's it. So this, we know from the previous video, we got to go into a double bracket situation, and we are forced to put 3x and x, because that's the only thing that can make 3x squared. And then, again, we're still trying to create this middle number 5. So our choice, so both the signs are positive because they're both plus. Again, this was explained in the previous video. So our choice is either to do, what have we got? We can either do 2 or 1 and 2. It has to be one of those answers. Let's take a look how that would expand out if we put 2 and then 1 first. So we do 3x times x is 3x squared. Then 3x times 1 is 3x. And then 2 times x is 2x. And I don't need to go any further because I can already see that's going to work. Because 3x plus 2x makes 5x. So you don't actually have to expand it out fully. Once you see it as you're working through it, you can just stop and immediately rule it out as being, incorrect or the correct answer. So in this particular instance, I arrived straight to the answer, and that took, 10 seconds. Now this last example is much harder because we have several multiples for the last number, and also the same can be said for the first number. But the method is still the same, and this is where the sort of trial and error aspect can come into it more, because you have to have a think about which multiples combine to give this middle number, and obviously there's more than one choice. So we have 63 times 1, 21 times 3, and then we have 9 times 7. And then on the first number, right, one thing from the previous video is that when the sign is plus, both of the signs go into the double brackets as minus and minus. And the reason why that is because a minus times a minus makes a plus. So now we have to select the multiples. And the question is, how do we know which set to begin with? Well, if you take a look at the middle number, the magnitude of that middle number is relatively bigger than 28 and 63, but it's not in the hundreds. So often you can rule out these first bigger numbers, because if I was to put in 28e and then e, we know at some point it's going to produce 28 times 63, which is going to be way bigger than 85. So that is just simply not going to work. So we can rule out the first ones as being unsuitable because of this likelihood of 23 times 63. And if we had the number the other way around, 1 times 63, we'd end up with 28 times 1, and then add in 63 for the remainder of the multiplication is not going to come to 85. So we can rule out the first set. Now let's try the second set. So we got 14 times 2 and 21 times 3. So I put 14e there and 2e there, and let's try 21 and 3 first. So 14 times 2 is 28e squared. 14 times negative 3 is going to be negative 42. 21 times negative 21 times 2 is negative 42. And I don't need to go any further because negative 42 minus negative 42 is not negative 85. it is negative 84. So what happens if I was to switch the 21 with the 3? So put the 3 there and the 21 there. Well, in this case now, what's going to happen is we go through the same again. 14e times 2e gives 28e squared. 14e times 21, so that times that, is going to give an answer much bigger than 85. So that is not going to work. So therefore, we can say the second set of multiples, 14 times 2 and 21 times 3, are also not going to work. Finally, we have 7 and 4 and 9 and 7 must be the answer. So let's try it out. Minus 49 minus 36 gives us minus 85. So therefore we know that this must be the correct factorization. So the trial and error method, you can see it's quite simplistic. It takes a little longer than perhaps other methods you've learned, but you do get to the correct answer. And trust me, once you've done 20 or 30 of these questions, you will quickly begin to recognize what are the correct multiples just by judging the size of this middle number. And then you'll get to the answer more quickly than you think. There's one left to do here. And what I've done is I've attached the answer scheme for this one below in the description. So please have a go at that one yourself and then check your answer. And don't forget to like and subscribe. And if you get stuck, please comment down below and I will get back and help you as soon as I can. Otherwise, thanks for watching and I'll see you in the next video.